Hello and welcome to another video by Meston Educational Services using the TI Nspire to write programs in Python. This particular segment is going to focus on writing programs pertaining to music and musical notes on Python. In this video, I'm going to show you how to use Python on TI Nspire to generate music notes and play the music notes. So I've just got a very simple two-line code on my screen, and to run this code all I have to do is to Control R, but I will first explain the code. So the code over here runs in a loop, and because there are 88 keys on a piano, this loop is going to run 88 times. So it's going from a range of 1 to 89 in steps of 1. So I'll go through each of the steps over here. So the first line that I've highlighted, that's the line 1, that's for the loop, and as I said, because there are 88 keys, it will go from 1 to 89. Then moving on to the next line, I'm saying print the text key. So whatever you see in green is a string, which means text, and then I is the iteration in the loop. Now you can go back to line 1 and see I have written over there for I. So I is the iteration. Now you don't have to use the letter I, you could use any other letter like X or M or anything. I just use I for iteration. So for I, so the first time it runs it would be 1, the second time it runs it will be 2, and so on. And then I'm leaving some space, so that's why you see the quotation marks with some space. So I want to, when I print, I want to have some space between the key number, and of course on the right I've got the frequency. So I'm going to explain that now. I've just highlighted that. So frequency, I'm going to generate the frequency. So I'm putting the text string FRE for frequency with a space, and then I'm saying I want to display the frequency to 2 decimal places. So that's the formatting for 2 decimal places. So I've got dot format, and now I've got the formula, which is 27.5 is the frequency for the first key, which I've written as 55/2. That's for A1. And then I'm saying go to the multiply this by 2 to the power of I is the iteration number minus 1 divided by 12. So I in the first loop is going to take the value of 1, then it's going to take the value of 2, and lastly it will take the value of 89, and 89 minus 1 will give me 88. So that would be for 88 keys. Now why are we dividing that by 12? Because there are 12 notes in an octave when you go from A to G, and of course you have the sharps and flats in between, but there are 12 notes. That's the reason I've got to divide it by 12. So if you do Control R, you should basically, now you can see I've just done Control R and it's giving me all the key numbers and the frequencies. For the frequency for the last key 88 is 4186 Hertz. And you can look for any key. So key number 80, the frequency is 2637 Hertz approximately. So this was generating the frequencies by key number. Now I'm going to actually graph this. So I'm going to use the TI hub import. Then I've got an empty list which has frequency, then I have an empty list which is called key. So I'm going to generate the key and the frequency. Actually in this particular one I don't need the hub import, that's for the next program, but anyway I've added that. You don't need the hub import over here because I'm not actually playing the notes, so I don't really need the first line for this one. The first part is very similar to what we did. So I'm running a loop command for I in the range from 1 to 89, and then for the frequency, each time the loop runs it is going to add the frequency to the empty list. So first time it's going to add 27.5, then the next frequency, and so on, and this loop is going to run 88 times. So the formula is the same as in the previous one. And now because I want to graph this, I've gone to import the module which is called the TI plot library as plot. I've set the window size as automatic. So I've used the two lists, key and frequency, that I defined previously. They will actually determine the size of the axis. I've just set the plot color, so red I've set it at 25, G is 0 and blue is 255. You can set any colors over there. Now you'll see I've got over there plot use buffer. I've commented that at the moment, but in the next run I'll actually uncomment that, and you'll note the difference what is the use of buffer. Then I'm saying plot the axis, and plot color. Once again I want the color to be different from the axis, and then I'm finally do a scatter plot of the key and the frequency, and the symbol that I'm using for the plot is a closed circle. So let's run this. So you'll see that's the plot, and then on top of that I've actually used the graph. So that's really the graph there. Now I have uncommented plot use buffer. Now you'll see actually it does the whole thing in one go. So you'll see everything happens in one go. So that's the idea of using the buffer. Okay, now actually I'm going to play the notes. So to play the note I need the TI hub. So you can see that's the innovator hub, and now I'm importing the TI hub module. So from TI hub import, and there's just an empty list frequency and same command, and you don't really need the second line in the for loop print. I'm just printing the frequency, and then I'm saying play the tone with the formula that I've got over there. So the second line in the for loop print is not necessary, but I've just shown that, and then I'm playing it for 2 seconds, but at the same time I'm putting a pause of 0.3 between each note. So that's the sleep. So now if you see when I run it, you may hear a sound. You probably have to really close in your ears to listen to this, because it may not be very loud. It's a small unit, the innovator hub, but you can actually connect it to external speakers and get a louder sound. So let's that was really it. Now the last one over here I've got is piano key notes to be displayed, actually one note at a time. So it says display each note and each key individually. So I'm using the TI draw import module, and I've set the pen to thick and solid over there. Then that's a color I've just selected. You can choose any color. I've selected a window size, and then I'm saying draw the text, and that's the position over there, 9-1, and I is my first text. Then I'm changing the color for the next display, and then again I'm using the draw text, and the first two is the X and the Y coordinates where you want the text to start from, and that's going to display the frequency. So the first draw is the key number, and the second draw text is the frequency, and there's a pause of 0.1. And of course at the end of it, it needs to clear the screen after each loop, so that you see actually a fresh display each time for each key and the frequency. That's why I've got the clear. So let's run it now. So you can see the blue is the key number and the brown is the frequency. And lastly, I've got option to display the key number, the frequency, and the note. So I'm using the for command, and this over here is a nested loop. So within a loop there's another loop that is running. So I've defined index IDX as 1. Then the values go from 1 to 8. And note, because there are 12 notes in an octave, so I've got all the notes over there. So the first note is A, the second one is A sharp or a B flat, then B. So So for instance, after C I've got C sharp and the D flat. So these are the notes. The black keys are the sharps and the flats, and the white keys are the plain notes A, B, C, and so on. So I've got the values from 1 to 8. So the first 12 keys will be 1A, then A sharp, then it would be key number 3 would be 1B, and so on. After 12 keys, then it will move on to 2, then after 24 keys it will move on to 3, and so on. So the last set of keys is A, B, and C. So 8A, 8B, 8C, and so on. Those will be the notes. So I'm printing the option. So go and print the key, the index number, then leave some space, go and put the frequency to 2 decimal places. Then I'm saying go and print the note, and the note, the value and the note would be printed over there, and each time the index value is increasing by 1, and I want it to stop at 89. So at 89, when the index value gets to 89, the loop will break. So let's run it and see. So you'll see all the keys are displayed. So key 88, it displays the frequency, and the note is 8C. If you were to look at key 80, the frequency is 2637.02, and the note would be 7E. And if I was to go right up, the first key would be key 1, frequency of 27.5, and the note would be 1A. So that's really it. Here I'm going to demonstrate how on the Innovator Hub I could use the sound note or the sound tone option to generate frequencies or the notes. So you'll see over here, the first one I've got a sound note of frequency 480 Hertz playing for 1.5 seconds, and then if I go further down, here I've got a tone where I'm playing a tone of frequency 600. But down here I've actually got a note that I'm playing, the B4 note for 1 second, and further down here you can see I'm actually playing a A sharp note, the 4th A sharp note on the keyboard. So you could use the note and the tone alternatively, but if you're using the note in terms of A's or B's, then you have to use the note, then you can't use the tone. So whereas for frequency you can use the tone and the note as well. So let's run this. In this program I'm using the 4th A note to generate all the frequencies from key 1 to key number 88, actually key 87 in this case because I've got 0 to 88, but I'm using the 4th A key which has a frequency of 440 rather than the first A key which has a frequency of 27.5. And I'm going to play the notes, and I've put a sleep of 0.3. And to conclude the video, I've just compiled a well-known Christmas carol. Some of the notes are slightly out of time because I don't have a music background, but I'm sure you can guess which of the Christmas carols this is.